This cantilever beam problem will be solved with SolidWorks Simulation with 1D beam element, and the result will be compared with the analytical solution. So if you're a mechanical engineering student who want to learn more about shear forces and bending moment diagrams and beam deflection, and have access to SolidWorks through your university, this video will help you. You can start by creating a new part, go to the front plane, create a new sketch, two lines for our case, because we have two beam elements, dimension it in millimeters, and exit the sketch, Control B for regeneration, and go to weldments here. If you don't have it, right click and you can find it here. Same goes for simulation, and go to structural members, choose the lines here and press OK. Doesn't matter the cross section because we're going to change this now. Edit sketch, delete the sketch, and create a rectangular sketch here. The following dimensions: 300 millimeters in height and 200 exit the sketch. Now we have our beam here. Save the part. The front plane, yeah, it looks perfect. We go to simulation, create a new study, name it if you want, static study. Apply some material. Young's model should be 210 gigapascal. Apply alloy steel. Fix the part, the end here, by choosing this joint, and create a point load in this joint here. And we're going to have a reference plane here, the top plane, and normal to this top plane we have 3000. It's going to be pointing downward, so reverse direction. Now the distributed load, go to force, choose beam. Now remember, don't choose don't write 12,000 right like this, because it's going to be 12,000 for this part and 12,000 for this part, because and the total is going to be 24,000, which is not the case. So remember, choose per unit length here, and 12,000 divided by 6 meters is going to be 2,000 Newton per meters, and it's going to be reverse direction, I think, because you can see it here. Oh, I have top plane, yeah, reverse direction, yeah. The forces, everything is fine. Run the study, and now you right click to in the result here, define beam diagrams. We are looking for shear forces in direction 1, in direction Z. So if you count 1, 2, 3, Y, Z, X, Y is the tension forces, and Z direction shear forces are direction 1, and shear forces in direction 2 is shear forces in the x direction. So we want to shear forces in direction 1, which is our case here. And you can choose scientific for the notation, 2 decimals. I think it's good. Oh, maybe it could be better. Floating, maybe. Yeah, I like it better. Floating, 0 decimal. Now, as you can see here, it's 15 kilo newtons. And we can create a bending moment diagram. Display, you can choose bending moment in direction 2. Once more, direction 1 in the y direction is not direction 1. 1, 2, 3, you can count 1, 2, 3. But the first direction is torsion, it's not bending. And then in the z direction is bending, but not in our case, direction 2 is the one we are looking for. Bending this beam in the x direction. So we choose floating, 0 decimals. And as you can see here, the maximum aligns with our analytical solution, minus 48 kilo Newton meters. I'm going to have this solution here. You can pause the video and go through the solution yourself. And now if you want to look at the displacement, you can look at here. Where is the front plane? Yeah, the displacement is 4.6 millimeters, also aligns with our analytical solution. Here is the analytical solution. Yes, don't forget to like and subscribe if you like the video. Thank you and see you later.